Thank you very much, Vivek. So we have time for some more Q&A.
And we'll invite actually Atul Verma as well as Peter Nuzil to come join us for the discussion.
All right.
I see. Hans,
please.
Go ahead.
Do you find differences between the bipolar, unipolar, and biphasic and monophasic? Is that different in MRI?
That's a good question. I have no answer because we haven't done any MRI in the early days of the, so I don't know. It's a good question.
Has anyone in their clinical series to date done follow-up head MR? One question that I have, I'm a believer that the gas bubble production with pulse field ablation is different than that we see with overpowered RF. I view the gas in overpowered RF as being a marker for overheating, and we know with overheating you get coagulum and can get emboli on that basis. And this, I think, is probably more electrolytic. I'm not sure. You said it's nitrogen. Do we have the gas?
Yeah, I don't know which gas it is for sure. What I can tell you is that just as Carr showed on that TE image, we uniformly see these eruptions of spontaneous cyclic contrast with every single lesion, sometimes more, sometimes less. And actually, after I finished making a comment, Cars, you had an abstract recently at ERA regarding this microbubble stuff.
Yes.
Let me just finish. So with regards to your question, though, we did do EGDs, and we will tell you tomorrow what the results are.
Not EGDs, cerebral.
Oh, I'm sorry, brain. I'm sorry. Yes, brain MRIs on a subset of the patients.
Okay.
So, Cars, you want to comment?
Yes, of course. So we also observed these gas bubbles, and we were, of course, alarmed by them and had to make sure that nothing bad happens to the brain. So that's why we did a preclinical study in dogs. You know that in pigs there is a capillary network which could prevent bubbles going to the brain. So that's why we invested dogs. And what we did is we gave an overdose of electroporation ablations, making sure that there was enough gas bubble formation. And we did baseline MRIs, we did at acute MRI, we did MRIs at 7 days. We did all sequences possible, and we didn't find any lesion.
Okay.
So that's very comforting, that's very reassuring. Of course, we don't know yet in humans if there's going to be any side effects, but from our first data, the patients didn't complain of anything, so it looks fine.
To that point, I just have a couple of questions about your clinical, and some of this data you may be presenting tomorrow. First, just a technical question. The lasso-like catheter, your ablation catheter, you said it changes from 16 millimeters to 27 millimeters in diameter, and yet you set the cutoff at 22 millimeter vein size or something like that. What's the reason for that?
Yeah, of course, we wanted to make sure that the catheter makes a good contact to the wall, because I thought you presented that you can have a 1 millimeter space between the electrode and the tissue. We didn't have evidence for that, so we wanted to make sure that the veins were not too big for the catheter.
And then the second question, I mean, it's been a while since you treated at least the first patients. Have you had any patients who had clinical occurrences that you happened to take back for a second procedure?
I cannot talk about that.
Okay, so that means yes, but you won't tell me.
Got
it.
Tell you.
Okay, and then last.
If I may, I'd like to follow up on the variable diameter lasso that you're using. So, is there any? Because if you use a slightly shorter diameter, then you have electrodes that are touching each other, or
yes,
are very close to each other. Is that an issue when you deliver? What kind of consequences?
We didn't see any issue, so we didn't observe any issue with that. We saw that the local impedance changed, of course, because when they touch each other, then the impedance changed a little bit, but we didn't see anything unusual. I'm not a physicist, so I don't know exactly electrically what can happen. Maybe René van Es can comment on that, but I didn't see any abnormalities.
And you have no concern, no? I mean,
until now, no.
Okay.
No.
And then lastly, on the safety side, can you just comment what if any safety issues that you've seen and what your plan is in the study that you're doing for safety evaluations?
Well, I think it's very important that we that we investigate all possible complications also in humans. We have done extensive testing in animals, but of course it's very important that we rule out every possible acute short-term and long-term complication in humans. But I think.
But what kind of evaluations do you have planned as part of your protocol?
Well, we are going to perform a second study, and in that study it's going to be a chronic study where we also will do testing like esophageal endoscopy, MRI studies. Yeah.
You know, one of the issues that we found, certainly in the preclinical and our clinical, which we'll share tomorrow, is that what you see acutely doesn't necessarily translate to what happens chronically. And so it's an important issue. And I'm wondering, Atul, I know that you're very involved with the Medtronic catheter project. What are your plans, as best you can share, in terms of what kind of studies you're going to do? What do you expect in terms of follow-up? Particularly, I'm interested, obviously on the safety side, but particularly on the efficacy side.
Yeah, so I think you make a very good point about the chronicity of lesions and how important it is to titrate the energy and the pulse form in order to get that chronicity. I'm going to answer your question in just a moment, but I was interested a little bit in the change from monophasic to biphasic. And Jacob, you had shown some, slides of the ventricular lesions and how with the monophasic you saw sort of a shrinkage in the area compared to some of the acute scar. And also when you were reporting on the pulmonary veins, you saw 100% isolation with the biphasic, whereas not quite 100% with the monophasic. Certainly, we've done a lot of animal chronicity studies, like out to 3 months, we've started with biphasic altogether, and certainly we see chronicity on gross pathology, not just on remapping. So I think there's a very high likelihood that with the biphasic we are going to see more of a chronicity. But maybe just a comment from anyone who's used the other technology about your monophasic experience and what you saw in terms of the chronicity there versus the biphasic.
Well, again, I can't tell you details, but we actually did see an evolution. So the data at the very end looked better than the data at the beginning. So I guess what I'm trying to say is this. We went into the clinical studies feeling very confident based on the preclinical studies. And yet, as oftentimes happens when you translate from preclinical to clinical, things don't quite work out.
Yeah.
So the durability data was not as good as what we would have initially predicted. And this required a lot of work of changing the waveforms, which, Raju back there does, but I don't understand. But ultimately, things improved.
No, absolutely. And I like your point. So just in terms of, what we're going to be planning for human studies, the Pulsed AF study is going to be starting sometime later this year. We haven't completely finalized the full study design, but certainly there are going to be aspects of the study to look at some remapping, for example, to look at chronicity issues. But as I said, so far in the animal data that we've done, we've been quite reassured by looking at the gross pathology about the chronicity of the lesions that are available. I think that any tweak to the pulse can potentially change a pulse from being therapeutic to either thermal, which obviously you want to completely avoid. There's no point in having another thermal energy source. And another tweak the other way can make it completely reversible. So, I think that's a point that I really want to emphasize. You guys have already made it elegantly, but just to the audience that, there really is a lot that goes into the design of these pulses, the design of the waveforms, and even just small tweaks can really change the nature of the energy that you're delivering.
I think there's sorry, go ahead.
I was just going to also mention that, just in fairness, there is another, company or energy source that's being used epicardially, mainly at the Mayo Clinic, targeting ganglionated plexi. And, we talked about nerve cells as being fairly resistant, and yet ganglionated plexi are relatively sensitive. And so why is that the case? And you can speculate that the cell bodies are non-myelinated versus nerves which are myelinated. Ganglionated plexi have a different shape versus long axonal neurons. But just to put it out there, that this is another interesting finding, that you can get the cell bodies very nicely with nervous tissue, and yet for some reason the phrenic nerve doesn't seem to be something that you can damage.
Yeah, I have to tell you, that aspect, of this black box aspect to it is very frustrating for me. Right. I mean, everything that we know is something that we've discovered empirically. I mean, I'm not able to predict anything. There's a question right there.
Yeah, actually, that ganglion plexi was my question. Did you see any vagal effects during the application?
Yeah, it's a good question. We actually did. We didn't always see it, but we certainly at times did see some vagal effects, which doesn't mean, by the way, that those ganglia were ablated. It just means potentially that they were stimulated, right? So we don't really know, I think. Any comments, Pierre?
Yeah, no, definitely I agree with what you just said. But to add to your point, when we deliver to the right veins, we capture the right phrenic nerve very consistently. So it's definitely captured but not injured.
And also, can you comment on adipose tissue, given the role that pericardial adipose tissue may have in atrial fibrillation? Is there a differential between myocardium and adipocytes in terms of the effect of PFA?
Oh yeah, definitely. Fat is terrible. Whatever energy you consider, it's a good insulator. But really working from the endocardium makes it not relevant. The fat is mostly epicardial, and I don't see a scenario where you would have a layer of fat protecting some more epicardial muscles. So.
But to that point,
from
though,
a surgical approach.
Oh,
Yeah,
sorry.
can I comment?
Yeah.
Go back towards the vagal effect. I think, well, to be fair, I think that we saw more vagal effect comparing RF, for sure.
Yeah. They're more
Even not on the left side, in the right side application. I completely agree with Pierre. He stated the phrenic is a different issue, but we need to discriminate between axons and between cells. So we have some vagal effect more than we are used to see with conventional therapy. Even cryo is different than that, okay? So, but it's a very interesting point why this electroporation is so specific towards the kind of cells, not tissue, but cells. So I think it's anecdotal because we are a little bit like backward, like maybe 20 years or whatever, 15 years ago, where we investigated like RF, right? So it's interesting because we have 3 different systems, right, of pulse field, right?
Actually, before this question, I just want Rick to address the fat issue. So specifically, obviously, for you, the fat does matter. Yep. So could you just comment from a technical perspective for the surgeons, if they're putting the ring around, what do you think, what did you have to do in order to negotiate the epicardial fat to make the lesion set?
Didn't do anything.
Nothing?
No. What we did find, in some of the initial patients, we didn't tighten the cinch for fear of producing folds in the atrial wall, thinking that may leave gaps. But we found actually just the opposite. When you tightened it up, one, we didn't produce any hemodynamic instability by snugging down with potentially impinging on the pulmonary veins, but that did not leave gaps. We did have some late gaps. Were they related to fat? I don't know. But the right superior pulmonary vein is one place where we did have a gap late in one of the patients, and but we haven't seen it anywhere else. So whether we're just snugging down and getting the whole antrum of the vessels, and we're getting maybe the ganglionic plexi as well, I don't know. But it seems to be pretty effective.
So Jacob, you want to comment on your preclinical experience?
Yeah. In the very early days, and I even forget what waveform you were using, but there was a difference in acute electrophysiological effects.
Wait, acute what effect?
Isolation effects between the sheep model and the porcine model, and the sheep model generally had more fat. So my impression from back in those days was fat did play a role in sort of stopping the effects of electroporation.
Like craning my neck. Cars?
Yes, well, I think in the issue of epicardial fat, maybe also monopolar versus bipolar can play a role as well. Because if you use monopolar energy, then the energy has to go through the tissue to the back patch. So I think if you use a bipolar catheter, then maybe epicardial fat will hamper your lesion formation. But if you use monopolar,
it's a good theory. I don't know how true that is.
That it has to go through the tissue.
Well, it still has to go through the tissue either way, right?
Go around
Not
it.
in a straight line.
Yeah, but if the electrode is small enough, it has to go through.
No, it can go around. It can
Okay,
go
maybe.
up, turn,
but
and go
to
around.
his defense, the ventricular lesions that you showed epicardially, even over the coronary, seem to not respect.
But pigs
the
do not have
planes.
fats. So
You're right.
Let's take next question, please.
We know that there are finite element models for RF and cryo, and I was wondering, there's a lot of black box features in what you're talking about. I was wondering if there's any finite element models. For example, Dr. Jace showed the difference between the flower configuration versus the basket configuration, and one was kind of a ring-like, the other one was a little bit wider. Is that based on the ability to, can you do numerical analysis and finite element modeling with this may answer some of the questions that you are posing?
Yeah.
I think you can do field modeling, and people have been doing that for decades, of course. So you can do an impedance map, and I think a very interesting thing would be to actually take a diseased heart and do an impedance map through SCAR, and you should be able to very well model the field distribution based on the electrode characteristics. I think the unknown is the biology side of it, and I think that's what all of us are struggling with, is the empirical observations without the explanation of what's happening on a cellular level to make myocytes more susceptible.
So let me ask you a question about limitations. I think most of us here on the panel have been pretty optimistic and encouraged about pulse field ablation. What do you see, and this is to anyone on the panel, what do you see as limitations to pulse field ablation? How can this technology fail, or how can it be limited for the various sort of applications that we need and use in electrophysiology?
Yeah, so I think one of the things that, first of all, is important for the entire field. There have been a lot of questions from the audience about the black box nature of this. Why is it tissue selective?
Yeah.
And I think it's imperative that as this comes out, that we also have the supportive data from the basic science aspect of things. Because we know that in general, EPs don't respond well to black box solutions.
We've been burned many times.
Yeah, we want to understand what we're doing. We want to be able to tell our patients what we're doing. And so I think one thing that I am reassured about is that I think this basic science data is rapidly developing in response to the fact that we're using this for ablation. And so certainly stay tuned for some of that data, but I think it's an important point for the entire field, regardless of whose technology that you're using. The other issue, and Kars, I was going to ask you this question. I mean, this whole question of monopolar versus bipolar, and getting to your limitation aspect, Vivek, having to use paralytics and general anesthesia versus being able to do this with conscious sedation. And with the monopolar, are you finding that it's pretty much a mandate you have to use general anesthesia with the patients?
No, we used it in our first MEN series per protocol. We didn't have to use paralytics. We used it in one patient to see if that was beneficial, but we didn't find it beneficial. Of course, there is some muscular contraction, but it's not to an extent that the patient jumps off the table. So that's absolutely not the case. You see some movement, but that's very comparable to a cardioversion. We are planning now the next series on the conscious sedation. So of course we also want to get rid of the general anesthesia, but that was just for scientific reasons, just to make sure that all circumstances were optimized for the first
I
one.
just want to reconcile that with our experience. Obviously, different waveform, different catheter design, and we probably can't compare directly. But and I wonder because when we did our 15 cases, we did do general anesthesia and we did do paralytics, but we never tried without it, and it was born out of our porcine experience where we had tremendous muscular stimulation. I mean, you know how it can be in those experiments. So because of that, we jumped straight to paralytics, and I'm glad we did, because we didn't want to deal with any issues. But I wonder if perhaps it'd be the same with us. We just never tried. And at this point, we're not going to try because we moved on to biphasic.
And with the biphasic, you're not experiencing, as you said, with the conscious sedation, the light sedation, you're finding that the patients are quite comfortable.
Oh, yeah.
Yeah, let me just be clear,
The
though.
question is light sedation.
Yeah,
right? So
I was going to
I
say,
would
it's not
be
light
very
sedation.
cautious to
Go ahead,
say.
Peter.
Okay. So what is the sedation is benzos and...
Sure, well, depends on the clinical practice in various centers. I don't know, in the US, if you are able
No, but
to
he's
use
asking what we did.
what we did. We did propofol because we can until we have proved that the patients could be awake somehow. So we call deep sedation, even with propofol, because patient is under our hands. But if we need to have more propofol, we need to ask anesthesiologist. Okay.
So Jacob, do you want to make a
I had
comment?
a question related to limitations, and I wanted your perspective about the role of contact with your technology and your technology. How important do you think contact was?
And how do you assess it? I mean, this is not an easy question, right?
Well, I think, one of we did a lot of ablation with the catheter positioned in the appendage with an intentional worst case, because you know that the trabeculae are holding the catheter away from the deeper recesses in the trabeculated tissue, and we uniformly saw transmurality in that setting. So we have a fair confidence, again, given the limitations of an animal model, that we have enough depth of therapeutic field effect that contact, yes, is important, or proximity is important, but contact, no. And I think that is worth emphasizing. Proximity is important, but unlike RF, where even a millimeter or half a millimeter of failure of contact will result in complete or substantial dissipation of the energy.
Even worse for cryo.
Yeah, even worse for cryo.
I would echo that. The proximity is an issue, and you can't just place the catheter in the middle of the left atrium and hope that it's just going to take everything out.
That's logical.
But on the other hand, it's not a contact-dependent technology.
It's quite, in fact, forgiving. This has been our experience, and particularly with the latest waveform that we have been using that are really powerful. I would like to ask you, Atul, David, and Kars, how do you see it in the future in your personal project? Are you going to move to dedicated generators and more refined waveforms, or do you think that the defibrillation type of waveform is going to be there in, let's say, 5 years? How do you see it?
I think, of course, there will always be a sort of an evolution. Now, of course, there are two systems. We use the monophasic single pulse. You use the PFA, the pulse fields. Nobody knows really what is the best. I think there will be maybe a mix. We have good experience with it. We don't see any complications. I have the feeling that our lesions are a little bit deeper. So from what I saw from your presentations, but I think nobody really knows. I know that we are working very hard on analyzing what is best for the future, but nobody really knows.
David, Atul?
We're using a dedicated generator. So
That gives you flexibility of lesion.
That's right. So
Waveform.
it's not a defibrillator-based delivery. It's a dedicated generator which it has the capacity to essentially have, if you wanted, an unlimited number of different varieties of deliveries that you could want. And certainly in the early days with the animal work, you know, there was a variety of different delivery models that were being tested. But, you know, you could have unlimited profiles in the generator.
And can I ask you why you did develop this generator? Because you had the DEFIB one. What kind of advantage do you see here?
Well, actually, so from the beginning, at least from the start of when I was involved, it certainly was a dedicated generator model. So we were not using a DEFIB model.
I think the concern with our team was right at the beginning, they were concerned about the legacy of DC shock ablation with barotrauma, vapor globe expansion and the like. And you guys have solved that issue, but one modern solution to that is just very short pulse duration. Then you have a problem of, well, one pulse is not enough. You need to get more energy into the tissue for therapeutic effect, which is why our systems are multiple very short pulses. And then with that, you have a cumulative effect, and then you, as we have observed, that one pulse train is not as good as two or multiple. And given our catheter configuration, where there is a gap, where the two edges of the circle meet, and there's a wider gap, we do, in fact, turn the catheter to assure circumferential lesion formation. So it's been an iterative thing, and as Atul indicated, their research unit had literally hundreds of protocols. The clinical unit is pared down to a handful of therapeutic protocols, but it's software driven, and I think as the suite of ablation tools increases, you of course will have to, at the very least, do modeling of field effects with different catheter surface areas, geometries, etc. And you may need to put in new profiles to match new catheter delivery tools.
I think it's fair to say that in our experience, we have seen some improvements from the initial experience with monopolar and monophasic waveforms to the biphasic and bipolar and short pulses, accumulation of short pulses.
But you can imagine the day where any catheter in testing right now, including the balloon electrode catheters that are out there in testing and the new Sphere 9 lattice catheter, these could all be used for pulse field energy delivery. And it's pretty exciting, but each catheter, again, will have to be tested with the optimized waveform.
Let me ask just a clinical question. You know, until now, we probably, fortunately, we as a field have been limited because of the efficiency of our catheters in terms of ablative capability, as well as the safety issues, which have sort of prevented us from, well, ablating too much, let's say. That's going to change very soon. Very soon we're going to be able to ablate whatever we want very quickly, very safely. And so this opens up the possibility of, well, ablation of everything in the left atrium. So I'm just wondering, as you think about clinical trials, because obviously, I mean, I say it's obvious. I don't think that's a good thing, right? No. We want some contraction in the left atrium, but how do you envision clinical trials moving forward in the future? I mean, it can't just be a sort of maniacal, you know, sort of goal of 100% efficiency, because you're also giving up some atrial contractile ability. So how do we design trials in the future? Pierre, you guys published a paper on the negative effects on mechanical function, you know, years out after multiple procedures. So how do we basically evaluate technology? It can't just be success, it's success plus something.
So the important aspect here is that we will be probably in the very unique position to really assess a given set of lesions, knowing that it will be durable.
Right.
And this is making absolute difference, because if you look at the 1-year AF-free rate, I mean, it's hard to interpret. Why did we fail? Is it a failure of the lesion set, so the strategy,
Right.
or did we fail because there was something else that we did not ablate? For the first time, I think that with this energy, it's going to be different. And if you do PVI, you really assess what PVI gives you in a given subset of patients.
Right, not just a PVI attempt.
Exactly.
Yeah.
Exactly.
Any other thoughts?
I also hope that we will have less micro-reentrant tachycardias due to gaps in the lines. You know, so if you make a roof line or an LA isthmus line, that when there's reconnection, you often get micro-reentry tachycardias. And I hope that now with durable lesions, we also will see less of those.
Definitely, but I think your point is very important. I mean, I'm afraid about excessive ablations in the left atrium, and even for persistent AF, I'm very happy with simpler set of lesions where we do not damage too much, and this should be really at least the first step.
Yeah.
And the first step shouldn't be extensive ablation.
Right.
I don't like the posterior wall isolation much, and even worse, the left atrial appendage isolation.
So when you think back to the very early days when we were first trying to wrestle AFib ablation away from our surgical colleagues, the issue of atrial transport function was what we always used to wave in front of the surgeons and say, but, you know, do your atria contract after your Maze 3 operation? And with our catheters, we'll do better than that. Somehow,
we've evolved.
That sort of went away. Polite conversation turned away from atrial transport function. And you don't hear people presenting papers on it. It's important. And I know there are people out there, not in my lab, but in my community, that keep ablating until there's just maybe 2 myocytes left in the left atrium. And there's no AFib, but there's nothing moving in the atrium.
There's TFLA syndrome, which is terrible.
It's awful.
I think this is an important concept that we can't stop the search for what is the ideal lesion set. You know, just because we now will potentially have the freedom to do whatever we want doesn't mean that we should do whatever we want. But, you know, I think Vivek, you know, even one of your criticisms of STAR-AF2 was that, you know, how do we know it was just a failure of durable PVI versus being able to look at PVI plus?
Not just STAR-AF2. I mean, it's a criticism of every trial we've
across
all
the
ever
board.
done.
Yeah.
Right. Yeah.
So I think it is, we are entering an exciting time where if we can, quote unquote, deal with the PVI problem, then we can systematically evaluate whether an additional line or a posterior wall isolation makes any difference whatsoever.
Jacob?
Yeah, it's a question. How much more of an incremental benefit in AF control does going from 80% to 100% durability get us?
Yeah, that's the question.
Right.
Yeah.
If you lose all atrial transport function,
Well, but
is it worth it? I
80%
don't know.
is a good result. We never get that in Bordeaux.
Any final clinical thoughts, Peter?
Actually, well, it's I like Atul comment because, you know, we can, as I stated previously, we are going backward, okay? Like leadless pacemakers, okay? We are going backward, okay? To investigate again the things, okay? And actually, for this, I think if we are potentially have 100%, I mean, no risk of reconnection, I would say, okay? So it means PV isolation is 100% durable 10 years. So how about to go to this strategy to repeat it? So go isolation first, then we know what we should do now. So mitral line, if it's mitral line is solid and effective, so go mitral line, or maybe roof line.
So basically, we have to do all the studies all
So
over
we need to go
again.
backward.
That's what we're talking about.
And it's a little bit crazy.
Crazy, but that's probably what it is. So maybe with that, I think it's about 10 or 15 minutes past when we're supposed to be here. So thank you, everyone, for staying. I think we're going to thank the panel. Pierre, you want to make any final comment?
No, well, thank you all for attending. I think there will be more of these events because this energy is going to keep us busy and happy for the next few years. Thank you very
Okay.
much.